A year on Jupiter is 3 times longer than Earth's year. A day on Jupiter lasts only 9 hours and 55 minutes. That means that if you were to live out the entire Jovian year, you would celebrate for New Year's in one Jovian day. Its atmosphere has these striking light and dark bands which stretch for thousands of miles. These bands are shaped by Jupiter's super-fast rotation. And it's not just the bands. Jupiter has giant storms that rage for centuries. These storms are also affected by its rapid spin. But how can such a massive planet rotate so fast without tearing itself apart? Hello and welcome to this channel. If you want to learn more about our amazing universe, then make sure to subscribe. If you want to study a planet's geology, its atmosphere is a pretty good place to start. You can see its composition by looking at what kinds of light pass through the atmosphere and reach the surface. With Jupiter, scientists have had an even easier time studying its atmosphere because it's so active. It has towering clouds that reflect sunlight very well, making them easy to spot from Earth. In fact, we think Jupiter's atmosphere is made up of mostly hydrogen and helium with some methane, ammonia, and water vapor mixed in. The atmosphere is divided into different layers based on their altitude. And like Earth, the higher altitudes get colder as you go up. But unlike Earth, Jupiter's atmosphere gets really cold at the top. We're talking close to absolute zero. What's going on there? Well, Jupiter doesn't have a solid surface to hold its atmosphere down. There's just more and more hydrogen and helium as you go lower. Now the pressure gets incredibly high deep inside that atmosphere, squeezing the gas into a liquid. And as the temperature drops off at the top of Jupiter, it forms a kind of cloud deck where the liquid hydrogen condenses just like water vapor on a cool bit of glass. That's why when we look at Jupiter, we see all those beautiful bands and swirls. They're made up of liquid hydrogen that's slightly different temperatures and slightly different compositions. But those beautiful clouds aren't just sitting there. Jupiter's atmosphere is whipped around by winds that can reach 618 kilometers per hour. That's faster than the speed limit on most German autobahns. The winds gather in huge tubes and flow around the planet. And because they're moving so fast, they form towering waves. These waves eventually break, creating the iconic white bands that crisscross the planet. And that brings us back to Jupiter's rotation. Because the planet rotates so quickly, it creates an enormous centrifugal force that pulls outward on the equator. This force makes Jupiter wider at the equator than it is tall, which means the equatorial winds have to move faster to keep the atmosphere from flying off into space. It takes about 10 years for a full band to make one rotation. So the wind moves about 400 meters per second. Scientists think that's just about fast enough to balance out the inward pull of Jupiter's gravity. As for those giant storms, they're thought to be similar to hurricanes and typhoons here on Earth, but Jovian storms are much bigger and longer lasting. We have seen several large storms on Jupiter over the years, but the biggest and most famous is the Great Red Spot. The Great Red Spot is a high-pressure storm system that has been raging on Jupiter since at least 1878. It is so big that Earth could fit inside it 20 times. And it is so long-lived that it has probably been around for hundreds or even thousands of years. Now, we don't know exactly how the Great Red Spot got started. Maybe it was just a small storm that grew over time. Or maybe something huge hit Jupiter and knocked up a bunch of material from the atmosphere. Either way, the storm is locked in place by Jupiter's rotation. Because it is sitting at the edge of a band that rotates faster than the rest of the planet, the air is flowing counterclockwise around the storm, and that helps keep it stable. The storm gets energy from the surrounding atmosphere, and that allows it to last for centuries. Now, Jupiter isn't the only planet that rotates really fast. Saturn rotates almost as fast as Jupiter, but the other gas giants rotate much slower. Neptune rotates about once every 16 hours, and Uranus takes more than 17 hours to rotate one time. So why does Jupiter rotate so fast? One possibility is that it was spun up by giant impacts early in the solar system's history. When the planets formed, they were surrounded by a disk of leftover gas and rock. Some of that material eventually coalesced to form the asteroid belt. But some of it also crashed into the planets themselves. And if it crashed into a planet near the equator, it would have caused it to rotate faster. Another possibility is that Jupiter captured some of the gas from the disk and that added angular momentum to the planet. Angular momentum is basically a fancy way of saying that anything that's rotating has a sort of momentum that resists changes to its rotational speed. For example, if you're spinning around on an ice skater's platform and you pull your arms in, you'll spin faster. That's because you're decreasing the moment of inertia, which is a measure of how hard it is to rotate. So if Jupiter managed to capture a bunch of gas, that would have increased its angular momentum and caused it to rotate faster. Of course, this is all speculation. We don't actually know why Jupiter rotates so fast. But we do know that its rotation has a profound effect on its atmosphere. It's responsible for the beautiful bands and storms that make Jupiter such an iconic planet. So next time you look up at Jupiter and wonder why it's spinning so fast, just remember that it's not just for show. Its rotation is a key part of what makes Jupiter the way we know it. Thanks for watching. If you want to learn more about our amazing universe, then make sure to subscribe.